Hello everyone, welcome to our session, what I call as the latest and greatest in Azure Networking. My name is Narayan Annamalai. I lead the products. You're not able to hear? Able to hear? Okay. Okay, so I heard some nods, so I thought I'd want to check. My name is Narayan Annamalai. I lead the products for Azure Networking. First of all, I want to thank you for coming here, and I'm passing through all the security lines, and thanks for being here. So if you're within these four curtains, we're going to be talking about networking for the next 45 minutes. If that's not what you wanted to do, you should go to a different set of curtains maybe in this room. But we'll get things started here. I'm going to invite DEEPAK BANSAL, who's a Corporate Vice President and General Manager for Networking, to kick things off.
Good afternoon, everyone. So we'll start out with discussing where we are with networking now and where we are headed. Then Narayan will cover some of the latest product innovations that we're going to announce today, and then finally conclude with real-world examples. So let me start by introducing what is Azure Networking, what is it that we do. So we build and operate the physical network that runs in our data centers. We build and operate the WAN that connects our data centers, as well as we build a slew of network services, 20 or so network services that almost every customer uses. That includes things like load balancer, virtual networks, ExpressRoute, VPN gateways. So anything to do with networking is what Azure Networking does. And our mission is to provide you with a seamless network, right? A network that you can instantiate with the click of a button or with an API call, a network that is reliable, that you can trust, that is secure and always available, because we realize that you run mission critical workloads on our network, and the availability of the network is super critical for your workloads. We want to provide a highly performant network that is planet scale, that can meet the demands of your workloads. And finally, we are building a network that is future ready, especially as more and more AI workloads are running on our platform. We want to make sure that the network is optimized to meet the needs of these AI workloads. And AI is a huge transformation that's happening in the cloud. It is getting embedded in all applications, existing as well as new applications, and AI is being run and integrated into these applications that are already hosted on the cloud or that are being built on the cloud from scratch. So let's look at what does AI mean and how we are evolving our platform, our network, to meet the needs of these AI workloads. So first and foremost, the AI workloads are driving a huge increase in bandwidth in the data center, right? We have GPU clusters talking to compute clusters and talking to storage, and there is massive amount of data that is flowing in between these GPUs and CPUs and storage. That may be the training data, that may be the data that needs to be fetched for inferencing purposes. So as a result, the bandwidth in the data center is rapidly getting increased to petabits per second. And it's not only the bandwidth inside the data center that we are having to increase, it's also the WAN bandwidth. Because what we are finding is the workloads are increasingly distributed across the WAN. GPUs may be running in one region, in one data center, compute and storage may be in another data center or another region. And hence, a lot of traffic needs to flow across our WAN. And we have been investing massively in improving the bandwidth of our WAN. While we were already running one of the largest wide area networks on the, in this world, we have turbocharged our bandwidth investments. We were running 2 petabits per second WAN capacity a year ago. Now we're running 4 petabits per second WAN capacity. So we doubled in a year. Similarly, the bandwidth connecting our zones within a region, we have tripled that bandwidth. While we were at 6 petabits per second less than a year ago, we are now at 18 petabits per second of WAN bandwidth that is connecting our zones to each other and our regions to each other. So a massive investment we are making to meet the needs of these AI workloads. Now, let's look at the network inside the data center. So AI workloads are redefining and reinventing the network as it exists inside the data center. We have a scale-up network. That's the network that connects GPUs within the same rack. Most of you are already probably familiar with the NVLink technology that we're deploying to connect GPUs within the rack. We also have a scale-out network that is used to connect those GPUs across racks. And these networks are very high bandwidth networks. And in addition, there is the classic Ethernet network that is the front-end network, and that's also getting a lot of upgrade because AI workloads demand such high bandwidths. AI workloads drive long-lasting, large flows because training requires a lot of data to be moved around. And most of this traffic is synchronous in the sense that traffic flows in bursts. And if there is any delay or any loss, the entire training job stops and has to be restarted from the previous synchronization point. So as a result, these AI networks in the data center have to be super reliable because any losses, any delay in the network leads to wastage of precious GPU capacity in the network because the whole job needs to be restarted from the previous synchronization point. We have to be very good at traffic monitoring and management because any faults need to be auto-remediated. We cannot count on humans to detect those faults and to recover from those faults because, again, the network has to be super reliable. And training workloads demand lossless traffic. They are not very friendly to losses, so this network has to deliver lossless within the data center. Okay, I referred earlier that GPUs may be distributed in different data centers trying to talk to storage in another data center. This may also include GPUs hosted in third-party data centers, the neo clouds like Nebius and whatnot. And so to connect these GPUs to compute and storage that's sitting in an Azure data center somewhere else in a secure fashion, we have to make sure that we provide very high bandwidth over private link to storage from the GPU clusters. To do that, we have developed a new technology that we call VNet appliance. This enables us to deliver high bandwidth privately from GPU to compute by leveraging what is known as DPUs, data processing units. So traditionally, we used to connect compute to storage privately by leveraging virtual routers, which were running on commodity servers. But they were becoming bottleneck for AI workloads. So what we did was, instead, we developed a hardware appliance called the VNet appliance, which is based on DPU, where we are able to apply SDN policies and provide that private secure connectivity from GPUs to storage. Let me show you a demo of what I mean by this and how we are able to turbocharge the bandwidth by leveraging the VNet appliance. So here what I'm showing is that we have 100 GPUs talking to storage privately using private link and private endpoints. And this traffic was flowing through a software router and was limited to 30 Gbps. But by replacing that software router by VNet appliance, we are able to deliver 150 Gbps, a more than 5x improvement in throughput by leveraging DPUs. This slide goes into more details of that. So when we were using a compute-based router, as I mentioned, we were getting 30 Gbps. And I'll let it play through. And by moving to virtual network appliance, we are able to improve that throughput more than 5x to 160 Gbps. The next slide will show that the bandwidth of each individual flow going from GPU to the storage. And you will see how it increased more than 5x by moving from software compute router to a virtual network appliance. So yeah, here you can see each of those lines show the throughput going from GPU to the storage via private endpoint. When it was using the compute router, the bandwidth was much lower, but by moving to a VNet appliance, the bandwidth increased dramatically. Further, we can scale out the virtual network appliances. So we can have the traffic go through multiple virtual network appliances, and by scaling out, we are able to achieve 5 terabits per second or even higher. This is the kind of bandwidth that we didn't even imagine anyone would need a year ago, but now we are delivering that bandwidth because the workloads, OpenAI and other training workloads are demanding that much amount of bandwidth. Okay, another area that we are looking at is all the network services that we have built so far have been built for cloud workloads. But are they able to meet the needs of AI workloads? And AI workloads are demanding new capabilities from network services. One such service is load balancing. While traditionally, load balancing is done on TCP or HTTP connections, but when we are talking about AI workloads, you have to take into account other aspects to do the load distribution, right? You may want to do model-aware routing. You may want to do layer 7 and MCP proxy through your load balancer. Similarly, the WAF and the security capabilities are dramatically different, or new kind of capabilities are needed for AI workloads because new kind of threats are emerging with AI workloads, prompt injection threats. So we have to build solutions for those kind of threats in our load balancing and security products. Caching is very different in the AI world, right? Now we are talking about semantic caching and not just content caching. So we have been thinking about and working on building AI-aware load balancing solution as part of the platform that we will bring to you. Another area that we are investing in is what I call AI perimeter, right? So today, customers leverage Azure Front Door to make their applications available on the internet. Now we are looking at evolving that Azure Front Door into what we call AI perimeter, where AI perimeter is able to provide you with a set of services that are specific to AI workloads. And I mentioned some of them already, right? Security services related to prompt injection attacks, observability improvements, prompt control, semantic caching, right? Caching, traditional content caching is no longer enough for AI workloads, and you need to cache at a semantic level. So those are the investments we are making to bring security to AI workloads, to democratize AI, and to make sure that AI workloads get the best capabilities from the network that they need to be successful. Okay, now let me hand back to Narayan to talk about some of the innovations that we have already made and are going to announce today that help both AI workloads as well as existing workloads. Over to you, Narayan.
Thank you, Deepak. Thank you, Deepak. So you all heard about AI and how we're going to make you be AI ready as you use our networks and Azure as your infrastructure. So let's spend some time on what we're doing for today's world, that when you go back to your desks on Monday, what can you use from the networking stack that's going to help you either be more performant or more productive or more cost efficient. So Azure Networking, we have always categorized or organized our solutions towards meeting the needs of customers, from building the networks, like many of the users could be in the stage of building of the networks in the cloud. And as the networks are built, connect them to either on-premises or to other clouds, distributed GPUs. And then once they have that, it's usually about like performance of the applications they run on the cloud. Right now, the utmost importance is security. As we are hearing about more of the security threats and cyber attacks, it's super important that you run these workloads in a more secure fashion. That's how we have organized our networking portfolio. And I also wanted to say, from the user journey standpoint, you could be in any one of these categories, right? So let's go from the bottommost layer. Most of the customers, or many customers, are either done with the migration cycle, where most of their workloads are already running in the cloud, or there could be still some stragglers or like the tail that is moving to the cloud. And to do that, this is where you need the most foundational network services, right? I call them, creating the virtual network to ExpressRoute connectivity or VPN to basic firewalls. These are all stuff that you need. So that is our most foundational layer. And as you are, maturing in the cloud, you are looking at, what are the ways in which I can modernize this estate. I mean, that's where our PaaS and SaaS services come into play. Think about our edge-based, AFD, or our application gateways, or our Bastion. These, services kind of help you, be more performant and more secure. And then towards the last end of the maturity cycle, you're building applications now that is cloud native, which are designed to take advantage of the cloud, where infrastructure is delivered to you as code. And this is not exclusive, because once you're building cloud native apps, you may need all of it below the stack as well. So this is how you kind of mature into the journey of running in the cloud. So today, I'm going to go through these layers and tell you at each layer what are the innovations, what are the new announcements that we are making that's going to help you, do your job better. So let's start with resiliency as the #1 thing, because right now the top priority for everybody running in the cloud is to be resilient, right? Never go down, and be resilient to zonal failures or whatnot. So today we're announcing in public preview zone redundant NAT gateway. Just show of hands, how many of you here use NAT gateway for egress traffic? Okay, as far as I can see, quite a number of them. Thank you. So NAT gateway is a beautiful concept because it auto scales. It gives you unlimited bandwidth to go to the internet. But NAT gateway today is zonal. You have to pick a zone in which to run your NAT gateways. So while that gives you some kind of isolation and seclusion, if that zone goes down, then you are not able to talk to the internet, which means you need to either run NAT gateways in all the 3 different zones and have some kind of a DNS-based load balancing or whatnot, and it becomes more management hassle for you. Today we're introducing zone redundant, which means our infrastructure we will deploy across all the 3 zones. You get to just select one NAT gateway, and that's like a regional NAT gateway. It is auto deployed across all the 3 zones, and we will take care of routing the traffic and all of that behind the screen, so you don't have to worry about it, right? It delivers performance 2x faster as well. It gives you full flow logs, which is awesome, and easy to manage, and IPv6 ready. The last thing, all of it at no extra cost. So same cost as what you're paying for a standard NAT gateway is what now you're going to pay for the zone redundant NAT gateway and get all of these functionalities. And very recently, as of today morning, the other hyperscaler also announced, but this has been in the works for us for some time, and we're going to be GAing this pretty soon. All right, cool. So now we talked about resiliency. Let's talk about scale. So we are pre-announcing that we will be introducing 400 gig ExpressRoute. So it feels like as if a few years ago we had a gig, 10 gig, 100 gig ExpressRoute. Now we are here in the era of AI, giving you 400 gig of ExpressRoute. So we'll have 400 gig native ports that you can connect to, that you can then take that to either an on-premises or to a GPU cluster running elsewhere. And this will be available early next year in a few locations, and then we will kind of deploy it across all our ExpressRoute locations where we have ER direct. Now, even though it is not in this slide, I also want to mention we are advancing on resiliency for ExpressRoute, where we always recommend customers to run 2 ExpressRoute circuits for max resiliency. For any workload that you run on the cloud that is production or mission critical, do not run them behind a single ExpressRoute circuit. Do max resiliency and run 2 circuits so that you don't lose connectivity if one of the sites goes down. On our side, we are running all the gateways in a zone resilient way, but we like you to run the site as well in a resilient manner. To make it easy, we have like the ER Metro. We introduced that last time. So ER Metro gives you the ability to run like one link to each of the different data providers in the same metro. We have enabled 15 more sites, and there are 8 more. So already we have like 19 sites that support ER Metro, and 8 more coming next year. So please, combining the resiliency with scale, please make sure that ERs are running resilient way. Now, on to the scale story. Again, the foundational service VPN gateway, we're announcing 20 gig throughput through VPN gateway, right? And each tunnel you can do up to 5 Gbps. So you may wonder, like, if you have ExpressRoute, why do I need VPN gateway? But many of the customers use them together. So ExpressRoute is your underlying backbone connectivity that obviously doesn't have encryption because it's fast and private, but some customers require IPsec-based encryption on top of that. So like the picture shows, you can have ER at the base and then still run through a tunnel on top of it. So many of our customers use VPN on top of ExpressRoute. So to give you the 20 Gbps on top of a ER 100 Gbps is useful. So we are still innovating on the VPN side to give you more scale, right? Okay. Right. So moving on, I talked about resiliency, talked about scale. I want to talk about security in our foundational services. So last year we announced DNSSEC and DNSSEC policy, right? And today we are announcing threat intel on top of DNSSEC. So what is it and why do you need it? So today, most of you use our Azure DNS for, let me maybe show of hands, how many of you rely on our DNS for resolutions of domains? A lot of them, right? So that's what you should be doing, right? You use a cloud DNS to resolve domains, and when you resolve domains, either maliciously or unintentionally, your users could be resolving to domains that are like malicious, right? They're like not the good domains, the bad domains, and you do want the ability to protect it and then not have them even resolve to those bad domains. So that is something that we are offering, again, as part of our opt-in DNSSEC policy at no extra cost. You can enable our threat intelligence. Microsoft has been collecting over the years all the intel about bad domains that are around the world. So we will use that to filter those things out for the users. So if they are looking up any of those domains, DNS won't even resolve the IP back to them, so we'll sever the connection right there. So this is security at the very early stages, and I would definitely recommend and consider you using that, because if you're already using DNSSEC policy, it's just an opt-in check-in button, and it just works for you right there. So please take advantage of that. And security also involves monitoring. You always need to know who's talking to who. So in Network Watcher, we moved from NSG flow logs to VNet flow logs. I hope many of you take advantage of VNet flow logs. So if we enable VNet flow logs on a VNet, every packet that the VNet talks to is being recorded for the 5 tuple. So you get to know who in the VNet is talking to and whatnot. But the side effect of this, it could generate volumes of data, because in a VNet, it could be very chatty. There could be a lot of traffic that is going across. So you do want to make sure that you are cost optimized. So you can do filtering on these VNet logs. So if you enable that, you only will store what you filter on. Again, a great way to optimize costs if you don't need all of these logs, and then you only need logs for specific destinations or whatnot. You can use a filtering feature, again, to kind of optimize cost over here. Right. Okay, I do want to introduce another service in public preview today, private link service Direct Connect. So it's a mouthful. You're wondering, what is this? Direct Connect seems like ExpressRoute. Private link service seems like private link. What are we doing with these two? It's exactly what we are doing. So what we are doing is, I'm going to explain this a little bit more so that you understand and how you can use it. So private link service today can be a front end of any service running in Azure and lets you connect to that service privately. So regular private link will give you connectivity to storage, SQL, Cosmos, probably using that a lot. But private link service, you can put that in front of any service in Azure. As long as the service runs behind a load balancer, you can put a private link service in front of it, and then you can connect to it from your VNet using a private endpoint. That was already there. What we're announcing today is extending that support to any endpoint behind private link service. So for example, let's say you have an on-premises endpoint that is connected through ExpressRoute, but not all VNets can reach it because of maybe overlapping IP addresses and whatnot. Everybody can reach that on-premises endpoint through ExpressRoute. So you had to either do a transit VNet with a full proxy. Some of our customers do that. They run a transit VNet in Azure, and then they run a full proxy to manage the overlapping IPs, and that's how they connect privately to the on-premises endpoints. Today, you don't have to do any of that. You can just put the on-premises endpoint behind a private link service. And once you do that, then you can do from any VNet in your Azure subscription, you can create a private endpoint and connect to that on-premises endpoint via that private endpoint. Again, no extra cost. You just pay for the private link service as before and the private endpoint cost. And now this enables you to bring any endpoint privately through private link to your users in Azure. If you imagine this, it could even be running in some other cloud, and you can put a private endpoint to reach that endpoint in running in some other cloud from Azure. If we're going to do a quick demo of this, so what we're going to show here, and Maria is going to come to help me out with the demo. So what we're going to show here is we're going to have the Azure side, where there's a private endpoint. In the Azure, we also have a private link service connected to an on-premises via ExpressRoute, and we're going to show you how the private endpoint is going to connect all the way to the on-premises endpoint. So this is on the right side, you see that endpoint is on-prem endpoint. If you see that IP address on the top on the browser, the calling client is 199. So right now we're reaching that the public way. So that's an on-prem endpoint. This 199 is the IP address probably of the ISP in this conference room. So now we're going to connect to that service privately. So what Mario is going to be doing is create a private link service. He's showing a private link service. And the NAT IPs the private link service will use are 10.114 and 10.115. This is going to be the private link service that is front-ending that on-premises IP. The on-prem IP is a 10.0.0.10 that is connected via ExpressRoute and sitting in the on-premises. Then we're going to show you a private endpoint. Well, this is the private endpoint, 10.116, my own private endpoint and my own VNet. That is going to connect to the private link service, which is going to then connect me to that on-premises endpoint. So next, Mario is going to be connecting from that VM using that 10.116 IP address. That has made its way all the way to the on-prem. And you see the calling client 10.115. That 10.115 is the IP address of the private link service NAT IPs I showed you. So what's happening right now is from the Azure VNet, I get to the private link service, and the private link service connects me to the on-prem IP address. And that's what you're seeing here. The calling client is 10.115. So this way, you can enable any endpoint anywhere through private link. That's the beauty of it, right? So again, there's no extra cost, just from private link service itself enables you. Thank you, Mario. Thank you. So moving on. So just to wrap up the foundational services section, so we're also announcing new limits for our services. Again, huge customer requests. So now, we used to have 1,000 private endpoints in a VNet. We are increasing that to 5,000 private endpoints. Now, using peered VNets, you can go all the way up to 20,000 private endpoints that you can access. That's a lot. But with the scale of where this cloud transformation is going, we feel that this is what everybody needs. On the Azure route server side, we used to have only 4,000 virtual machines that the route server could reach to. Today, we're announcing generally available 50,000 virtual machines. Now the route server can reach to. That gives you enormous scale on customizing the routes for the VMs and the VNet. Okay, now I'm moving on to the next side of modernizing your network design or your network usage in the cloud. Let's start with virtual WAN and what is new there. So virtual WAN, what we're introducing is a force tunneling for virtual WAN secure hubs. So if we have like a 0/0 route coming from ExpressRoute or going towards ExpressRoute, virtual WAN was sending it directly. Instead, now you can put a path in between. So you can go to the virtual WAN and say, before you send it out to the on-prem or on the way back, make a stop over an Azure firewall and secure hub. That's generally available. This seems like a small feature, right? But this was available in do-it-yourself hub and spoke. It was not possible in vWAN. Those who have been using vWAN, how many of you use vWAN here? Let me ask that. Okay, a good number, right? 10 to 15 people. So you know this was a pain point. In vWAN, you couldn't do force tunneling through a firewall or a NVA. We are removing that restriction right now. You could do firewall as a GA service, and you can do another NVA, a third-party NVA like Palo Alto's. In preview, you can do that stopover. Okay, so that just shows you a different way to use that. Okay, this is a feature that I'm quite excited about. So in public preview today, we're announcing that App Gateway can handle the JSON Web Token validation, right? So what does that mean? Like you're thinking like what the big deal? So the big deal is, so many of these client applications can go get a token from an identity provider that proves who they are, right? And then they need to present this token to the final backend server. And the backend server needs to validate this token. These tokens needs to be validated because you just can't trust that somebody gives you a token, the token is good. You need to know the token came from the authorized service. The token is for this particular user. That this user can actually access those backend endpoints. And the token is currently valid, and it is valid at this right time. It's not valid before or after a certain point in time. These are all regular checks you got to do on a token. Now, when App Gateway was on the front end, we were not doing these validations. So if we got a token as part of the request, we'll pass it on to the backend server. And the backend server had to do this validation, or the backend server had to call into another service to do this validation, right? It was an extra hop, extra cost for customers. Now, with this announcement today, Application Gateway can do this validation for you at no extra cost again. So it will do all of the checks and balances of the validating this token, and if the token is valid, it will pass it on to the server. Otherwise, it will drop the traffic. So that's a huge cost savings for you, and makes it easy for the workflows. Okay, now I'm moving on to the last bit that you saw, cloud native. So when you're running cloud native applications in Azure, you need high-speed networking to go with your managed Kubernetes or your pod clusters. And we have introduced, and do people know our Azure CNI? How many people use Azure CNI and ACNS? Some of you. So for others, let me tell you that Azure has its own CNI built off of Cilium. And we have also created a networking package called Advanced Container Networking Services that can be easily deployed with an AKS cluster. Now, this ACNS is based off of the Cilium open source. So it uses eBPF on the Linux data plane, on the Linux kernel, to automate many of the network functions for you, and does a lot of policies. So mainly it does a lot of monitoring and kind of metrics, and it does security, and it improves performance as well. So that's the ACNS as a package. And there's a lot of new announcements we are making on ACNS. So let me walk you through some of them. So number one, just by using our Azure CNI, there's a second bar over here, you get 9% performance improvement. What does it mean? So when a pod to pod, when you are deploying an AKS cluster, when a pod talks to another pod, if you're using like bring your own Cilium or some other Cilium, the throughput is, let's say, X. So when you use like Azure Cilium, that throughput goes up by 9%. You get 9% more performance boost. The reason for that is we remove double encapsulation. So when pod to pod is talking, there's usually encapsulation happening at different layer, because the pod IP is then wrapped in with a VM IP that's get wrapped in with the host IP. That's how the routing and networking works. So now when you use our Azure Cilium, we remove one layer of encapsulation and directly use the host IP address to do the routing. So that gives you performance boost. That is 9%. Now, when you use our new Azure CNI powered by Cilium with the eBPF improvements that they're making, you get an additional 40% improvement. So taking all the way to 49% performance improvement for pod-to-pod networking, which is huge. And along with performance gains, we also have layer 7 policies, which is FQDN-based filtering for any kind of pod traffic that is going out, and then obviously more enhancements on metrics and observability. And we also have enabled encryption between port-to-port traffic using the WireGuard. So host-based encryption using WireGuard. So using ACNS with AKS, which is again an option. If you use AKS automatic, you can opt into this. It's a great way to get best networking for your Kubernetes workloads. Along the lines, I also want to say our web application firewall is now GA for App Gateway for containers. So for people who are using our AGC solution for layer 7 load balancing in Kubernetes environments, we didn't have WAF along with it. So the customers had to use application gateway itself to do the WAF, or use some other third-party WAF for it. It's extra cost and more maintenance. Now we're just enabling WAF on application gateway for containers. So a one-stop shop for both load balancing as well as security for L7 traffic. So that is generally available, so it makes it easier to manage that. So also, this seems like a small feature, but a very useful one is that how many of you use Bastion here? Yeah, thank you. Because we are trying to get rid of any public IP directly on the VM. So it's bad practice to use public IP for RDP or SSH for your VMs. The preferred way is to use Bastion, which you connect into the Bastion. It's like a jump box as a service kind of a thing, right? And it connects to that RDP SSH privately. So that was what you use for VMs and take out the public IP address. Now you can use the same concept now for private AKS clusters. Because private AKS clusters are very popular. Many customers use AKS clusters in a private mode. But if you want to connect to the private clusters from outside, you either had to create a public IP address, or you have to run your own jump box in the VNet. Now we don't have to do any of those. So Bastion in itself can extend itself to connect to the private AKS clusters as well. So just by using the existing Bastion that you have in your network already, you can use that to connect privately to your private AKS clusters. Again, simplifying your overall experience and one less thing to worry about. Okay. Next, I do want to show you a video from our customer who probably is a great example of cloud native. So they've been using Azure for all of their needs, and they've been like a born in the cloud kind of a customer who has been like running their service in Azure and scaling up and down very fast. And our control plane has kind of provided them the ability to do that. And I'd like to just play a video of their testimonial.
Snowflake is the data and AI platform enabling customers to drive breakthrough business impact with a trusted data foundation that simplifies advanced analytics, AI, data collaboration, and more. Customers leverage the Snowflake AI Data Cloud, which combines the Snowflake platform with the Snowflake connected ecosystem of organizations to innovate faster and get more value from data. Snowflake is used by customers around the world to answer more than 6 billion queries per day over exabytes of customer data. On Azure, Snowflake is currently serving customers with over 100,000 virtual machines across 17 unique regions. Strong customer demand is driving both scale up in existing subscriptions as well as scale out across new ones. One of the core premises of Snowflake has always been to scale the compute and storage demands independently, and Azure's been a great partner on this. We're able to scale up our compute demand immediately in response to customers' queries. We've partnered closely with Azure to use the new Fleet APIs to reduce our end-to-end provisioning time. The faster we can provision new virtual machines on Azure, the fewer machines we need to keep in a warm standby state, and thus we can further improve efficiency and reduce our costs. Snowflake stands also as a leading adopter of Azure Private Link, leveraging this service to enable secure connectivity between a customer's virtual network and their Snowflake accounts, ensuring all traffic remains on the dedicated and secure Microsoft backbone. This innovation reflects the strength of the Microsoft Snowflake partnership and our shared commitment to providing scalable, enterprise-grade solutions that meet the highest standards of privacy and compliance. In the case of inbound connectivity, Private Link allows clients within the customer's VNet to connect to Snowflake securely via private IP addresses. These connections can be via Snowsite UI, via drivers such as JDBC, or SnowSQL. Snowflake also uses Private Link for outbound connectivity, securing traffic originating from the Snowflake platform to customer-owned resources. This allows customers to connect privately to Iceberg and Open Lakehouse resources and to read and write bulk data to a customer's private Azure Blob storage containers. So what's next for Snowflake and Azure? We're very excited to partner with Azure on many fronts. On the compute side, we're excited about the next generation Cobalt 200 virtual machines. Azure has been an excellent technical partner with their ARM offerings, often working side by side with our engineers and bringing up our system on the new platforms and helping to investigate performance anomalies to ensure we get the maximum price performance benefit. On the networking side, we're excited to continue working with Azure to scale out the usage of private link for our largest customers and to enable easier network boundary configuration using Azure Network Security Perimeter and public IP prefix. This includes scaling up to a larger number of private endpoints and VNet limits, larger storage firewall limits, and working towards greater network mobility for our customer workloads. It's been exciting to be a part of all this great progress, and we're looking forward to continue to grow our partnership with Microsoft to help our customers activate their data and deliver AI to every enterprise user.
Yep, so that was a great testimonial from Snowflake. So if you didn't know, Snowflake can be accessed completely privately in Azure over a private link. One of the things that they mentioned about Azure Cobalt 200, which we announced yesterday, it's coming next year. Today, Azure Cobalt 100 serves a lot of customers with great price performance. So a few things I want to also capture. Some of them, they're going GA. We talked about these last Ignite. They were in preview state. Some of them went GA over the last few months. So Network Security Perimeter, which is a great tool to secure PaaS services, which I call as a unified PaaS firewall, is now generally available. Same with Application Gateway TLS Proxy. We had it in preview. That is now GA'd. And ExpressRoute Max Resiliency has been there in GA. And we have Max Resiliency Insights also in GA form. And on extended zones, we still continue to take compute closer to the user, having Azure experience close to the user. So we announced Perth as an extended zone region that is actually GA as well. So if you are from that area, or you have customers, or you work with somebody in Australia, Perth is a Azure extended zone that is already in a GA fashion over there. So with that, I would like to remind you to go and attend a few more sessions. Hopefully, you still have more to do in this conference. So attend our sessions Thursday and Friday, and please do go to Azure Networking, AKMS Azure Networking for all our docs and latest information. And thanks for coming. Hopefully, it was useful.